Yo, we're reacting to something different. Will quantum computers make time travel possible? That sounds absolutely quality. Let's get straight into it. And away we go.
What do you hope technology will achieve in the future? There are so many challenges and possibilities
don't think we should do time travel
for humankind. But of all the sci-fi superpowers that we could develop, time travel surely ranks high in terms of its potential to change the world forever. So, are we almost ready to finally make that breakthrough?
What sort of logic would we be going on the time travel? Would we, if we changed the past, would we affect our future as it is, or would we affect another time stream future that we would be living in? That's the real question I want to know. It's kind of a weird concept that I don't suppose we will ever know, because even if they do change the past and it changes our future, like us now, we wouldn't know if we've already done it or not. So it's kind of a weird, scary thought.
This is Unveiled, and today we're answering the extraordinary question: will quantum computers make time travel possible? Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content.
True, make sure you hit that subscribe button.
The debate surrounding time travel is as old as, well, time. For decades, even centuries, humanity has been considering whether it could ever be possible to move not only through our spatial plane, but also through a temporal one as well. More so than just into the future 1 second at—
That's another thing as well. If we've already, like, if in the future we've already discovered time travel, why have we not already experienced the changing effects of time travel already, if that makes sense? Because we've already in the future going to discover it, but then we haven't done it physically in the present day. I don't know, I'm confused myself.
At a time. Rather, we're after true four-dimensional living, where the past is never truly over, and the future is always worth a visit. The flux capacitors of Hollywood films have certainly inspired imaginations over the years, with the quest for time travel almost inevitably bleeding over into the race to achieve faster-than-light movement. But now, with arguably a new age of technological exploration only just beginning, have we finally found the key to open this particular door?
Should
Theories
we?
surrounding quantum physics are hardly new news in themselves. For much of the 20th century, scientists were busily getting to grips with the subatomic realm, describing atoms, splitting atoms, and discovering all of the even smaller parts that make even the atoms themselves look like vast and complicated structures. Today, the quanta, the tiniest packets of reality, are reasonably well known. And though the standard model remains an incomplete and ever-evolving concept, we are now putting it to practical use in the here and now macro world with quantum computing. This is something we've covered in previous videos, but to recap briefly, because actually, it could actually be crucial to the question of time travel specifically. While traditional computers carry standard binary bits of information understood as ones and zeros, the quantum bits, or qubits in quantum computers, can be either a 1 or a 0. This freedom dramatically expands the processing power they offer, and it's here where the genuine possibility for time travel comes in, because some believe that quantum computing will actually be powerful enough to bend and break the rules of time. We already know that at the quantum level, the laws of physics somewhat fall apart. Quantum entanglement enables apparent speed of light travel. Quantum data can easily move between wave and particle states. Quantum superposition enables chunks of subatomic information to apparently be in two places at once. We know that all of that's already true. So, next stop, traveling back into the past. And multiple experiments seemingly have already shown that it is possible.
What?
Perhaps the first
No
murmurings
shot.
of quantum time travel came in March 2019, when details emerged of a multi-authored paper from an international team based in Russia, the US, and Switzerland. According to a report from the Moscow Institute of Physics and Technology, or MIPT, physicists were able to reverse time using a quantum computer. To set the scene, the MIPT explains how an isolated electron in a vacuum of interstellar space, i.e., how the tiniest bit of reality in the least chaotic conditions in the universe could, theoretically, be smeared between the present and the past for a tiny fraction of a second. It's suggested that a random fluctuation in the cosmic microwave background radiation, or CMB, might achieve this, although the chances of it happening are extremely, extremely low. As the MIPT puts it, even if you spend entire lifetimes of the universe again, watching 10 billion plus electrons for every second of that existence, then you'd only see an electron smear back in time once, and only for much less than a second when it did so.
Terrible.
Scientists are patient people, but they're not that patient. So the team set about applying what they knew to a quantum computing exercise, hoping to crunch those incredible odds all the way down so they could eventually reverse time on demand. And to some extent, they succeeded. Using a relatively simple 2-qubit setup, they were able to set those qubits into life before effectively pausing them and sending them back to where they came from. Back in time, all the information within effectively untouched, and order seemingly restored out of growing chaos. With the 2-qubit computer, the team was successful 85% of the time. When they added a 3rd qubit, that rate dropped to 50% of the time, and were they to have added more, the rate would likely have continued to fall with every added complexity. But nevertheless, on some level, this could be described as real, true, observable, and possible backwards time travel. Just over a year later, in July 2020, news broke of a joint research project out of Los Alamos National Laboratory. Here, in a study involving another quantum simulator in a similar, although not identical setup to the MIPT experiment, researchers were able to show that the fabled butterfly effect didn't take hold at the quantum level. The butterfly effect is the theory that even small changes in the past can massively alter the present, and the same to the present into the future. But when the Los Alamos team ran qubits through their quantum processor,
there was no butterfly effect?
As through back into the past, but then altered them ever so slightly, it was found that very little effect was still noticeable when those qubits were brought back to the present. They hadn't carried the altered information through in any—
So no matter what happens, everything's predetermined. But what if you killed someone? Like, okay, so if this is true and the butterfly effect doesn't happen, if you killed an important figure in like history, would it not affect the way of life? So for example, if you went back in time, killed Hitler, would there still be like a replacement for Hitler, as I'm guessing? That's what it's trying to say? Like, it's only on the quantum level, so I'm guessing it's very tiny and minuscule compared to what I'm talking about. But yeah, would it just not affect the course of life? Yeah, well, this changes things. We can go back anytime we want then if it doesn't affect anything.
Any meaningful way. Could this, then, be a sign that quantum time travel is not only possible, but potentially safe as well?
Yeah, that's what I'm thinking.
In late
but then again,
reports were that there have been 2 independent studies published within days.
That also makes the question, if you save someone's life that shouldn't be alive today and then bring them into the future, would that stop? Would that, because they're out of, there's no butterfly effect, words that kind of get out today, so there's no butterfly effect, so it wouldn't affect the previous time that you've done. They would have disappeared, but you brought them into the future. Dude, this is crazy. I like this idea.
Days of each other, both achieving a quantum time flip, specifically with photons, the subatomic particles of light. This time, It wasn't a quantum computer at the heart of the experiment, but a specifically structured crystal. Although it's claimed that there could be major implications for quantum computing in the future. In short, the studies passed split photons through the crystal, making use of quantum superposition. And upon measuring them afterwards, when they'd recombined, they found that while one split had continued along the expected arrow of time, the other had turned against it. At its heart, this could be seen as in direct defiance of the second law of thermodynamics and entropy, probably the trickiest barrier between us and time travel in general. Ordinarily, entropy says that everything is always moving from order towards disorder or chaos. It never goes the other way, which is essentially why we have the concept of time moving forwards in the first place. But here, with photons shot through a crystal, it would appear that actually, to some degree, physical matter and energy can move in the opposite direction, in an anti-direction. Although the fact that the photons are split is important. Ultimately, this isn't time travel just yet, and certainly not in any practical sense. It's more a parting of ways at the quantum level, and yet another subatomic mystery for science to add to its growing list. Utilize those or similar crystals within quantum computers, though, and the already boundless states of a qubit potentially increase even further. The possible processing power soars again. For now, with all three of these studies, we can't truly claim that time travel has been discovered via quantum computers. But could these projects yet prove to be the seeds for even greater ideas and breakthroughs? Today, we're smearing qubits back into their own past, recording how changes do and don't register.
See, that's the sad thing about science. Like this could be like a big breakthrough today, or in some respects, like for a bit. But then this could like meet a dead end, and then no one even focuses on this theory any longer. And in about like 50 years' time, some other fella picks it up and goes, "Well, they missed this," and then the big discovery's then, which is kind of a sad thing. It's kind of like the thing like where if you focus too much on one thing, you get like brain fog and you can't continue. It's kind of like that. So it's kind of sad in a way that might not be alive to see it, but you know.
And sending split particles,
we were there when it was semi-discovered.
Realm. There's still a long way to go, and a major scaling up operation that needs to happen. But still, that's why quantum computers might one day, perhaps, make time travel possible.
I was baited! I thought they discovered it! Will quantum computer... Oh, no, it's just a question. Okay, I thought they generally did discover something crazy, but to be fair, we would have heard about it all over the news and not on a YouTube video. So anyway, that was a good video. Make sure you check out the original video in the description down below. What are your thoughts on time travel? Do you think it will be someday possible? And will it affect us in the long run if we do it? Should we, in fact, not discover it to save our own skins? Anyway, I will see you in the next video. Make sure you subscribe. Laters.